Hello students, welcome you all to this online lecture session. Myself Prerana Shinde, working as assistant professor from the Department of Chemistry in S.VK.T Arts, Science and Commerce College, Nasik, Debroglie camp. So, in this lecture we are going to deal with the quantum chemistry from the chapter, which is the chapter included in the TYBSc semester 5th. So, today we are going to see the basic difference between the classical and quantum chemistry. What is the black body radiation, photoelectric effect, next to that the Debroglie hypothesis and the uncertainty principle. What is the difference between the classical and quantum chemistry? The classical mainly applicable for the macroscopic object, the object that we can see easily, and the quantum chemistry it is for the microscopic object. The microscopic object are electron, proton and the neutron, or which are the atomic level. Quantum is basically for the atomic and the molecular level. In that particularly that going to see the black body radiation. So, what is a black body? First of all, the body which absorbs and emits the all kind of wavelength called as a black body, and the radiation emitted by body is called as the black body radiation. If you see the example of a particular body, there are three different phenomena occur. First, if the light falls on the body, it reflects light, it transmits light or it absorbs light. Black body basically deal with which absorb the all kind of radiation and also emit the all that radiation which is absorbed by the body. Sun is the perfect example of what? Black body, which emits the all different kind of wavelength. The wavelength included are the IR, UV, visible, radio frequency and the cosmic rays. Because of that, in a summer we not used to prefer the black clothes because they absorb the all kinds of wavelength, and because of that there is an increase in the temperature of the body. Next we are going to see the example or the example of black body. Here is a picture which shows the black body or which absorbs the incident radiation and also emitted that radiation. Next is the photoelectric effect. What is the photoelectric effect? The ejection of an electron from the surface of metal by electromagnetic radiation is called as a photoelectric effect, and the ejected electron are known as a photoelectron. The phenomena is like a if you taken the surface of a metal or the metal plate, when the light falls on that metal plate, there are some electrons which ejection of that electron. In solar panels, in electronic cameras, generally this effect we can see, that is the photoelectric effect. This is the picture for the photoelectric effect. This is a metal plate which in which the electrons are there. When the light of certain frequency or light rays falls on that plate, there is a emission of a electron. In this effect, there is a ejection of what? Electron. So, here we can say that there is a light has a two nature. Light has a two nature, that is a wave and the particle nature. In a photoelectric effect, we are dealing with the particle nature of the light. The next is what? The Debroglie hypothesis. As we know, the light has a dual wave particle dualities, that it can behave as a wave and the particle. But the properties of wave and the properties of particle, are they are same? So, Debroglie has statement, that is the on the basis of what? The momentum and the wavelength of what? Particle. Can particle also behave like a wave? Wave has two properties, that is the interference and diffraction. Can particle has these two properties, that is the interference and diffraction? From that conclusion, he stated a statement, that is the relationship between the momentum and the wavelength of light should also apply to the particles. The Debroglie relationship states that lambda is equal to h upon mv. Here lambda is the Debroglie wavelength, h is the Planck's constant which equal to 6.6 into 10 raised to minus 34 joules second. M mass of a electron, v is the velocity of a electron. P is equal to mv, which is a movement of electron. So, the formula also like a lambda is equal to h upon p. From that we can calculate, if we know the, here it is the Planck constant is a constant term, mass of electron that we know. By changing the velocity of that electron, you can calculate the wavelength of that, or the de Broglie wavelength. Next that we are going to see, that is a Heisenberg uncertainty principle. So, what the Heisenberg uncertainty principle? It is for the microscopic object. Again, the microscopic object are the electron and proton. What is stated? According to the uncertainty principle, for a microscopic object, it is impossible to know simultaneously the momentum and the position of particle accurately. That is a delta x into delta p greater than or equal to h upon 4 pi. Delta x represent the position of particle, delta p represent the momentum of that particle. Particle you can say as the electron or the proton. If you taken a quantum wall or a particular box, in that if you know where is the position of electron, but you can't state the momentum of that particle. Either you can state the position of electron or the momentum of particle. And if you calculate both the terms, there is some minimum uncertainty in this value, in any one of the value. So, delta x, that is the position of electron, and delta v is the velocity. You can also find out from the term delta p, or momentum of particle, that is a mass into velocity. From that you can calculate also the velocity for that particle. So, here it is the assessment for you people. Write the application for the photoelectric effect that we are using day to day life. And second is the, what is the uncertainty in momentum if we wish to locate an electron within an atom, that uncertainty in position approximately 50 picometer. Uncertainty in position they have given delta x, they are asking about the delta p, that you know the relation is equal to h upon 4 pi. H is the Planck's constant. From that you can easily calculate the uncertainty in the momentum. Here you have to use the formula delta x into delta p is equal to h upon 4 pi. Pi you can take 22.7 also. So, summary of this lecture, what we have seen here, the light has a wave particle duality explained by the photoelectric effect and the de Broglie hypothesis. In a next lecture we are going to deal with the quantum number. In that we are going to, there are 4 quantum numbers: the principal quantum number, azimuthal quantum number, magnetic quantum number, and the spin quantum number. Thank you.